The modern anti-skid processes are based on the use of a computer whose input data is idle wheel speed measured, braked wheel speed measured, and desired idle wheel train slipping rate.
The highest load on the torsion link in a bogie gear is, whilst turning on the ground with a small radius. An underinflated tire will experience increased wear at the shoulders.
Compared to a tire fitted with an inner tube, a tubeless tire presents the following characteristics: lower risk of bursting, better adjustment to wheels. The reason for fitting thermal plugs to aeroplane wheels is that they release air from the tire in the event of overheating.
If the profile grooves or the tread of new aircraft tires are worn, the tires can be repaired several times.
A tubeless tire is a tire which requires solid or branched wheels, which does not burst in the event of a tire puncture, and which eliminates internal friction between the tube and the tire puncture and would tube in the tire. A tubeless tire has no built-in air tube and a radial side casing.
During hydroplaning, the friction coefficient between tire and runway surface is approximately 0.
To avoid the risk of tire burst from overheating, there is a thermal plug that deflates the tire at a specific temperature. The maximum permitted creep is indicated when the edge of the tire mark aligns with the opposite edge of the wheel mark.
The working principle of the anti-skid system is reduction of the brake pressure at the slower turning wheels.
The illumination of the green landing gear light indicates that the landing gear is locked down. On a modern aeroplane, to avoid the risk of tire burst from overheating, due for example to prolonged braking during an aborted takeoff, there is a hollow bolt screwed into the wheel which melts at a given temperature, thermal fuse.
The function of a fusible plug is to protect the tire against explosion due to excessive temperature.
The purposes of the oil and the nitrogen in an oleo-pneumatic strut are: the oil supplies the damping function, and the nitrogen supplies the spring function. The part of the flight that will cause the highest loads on the torsion link in a bogie gear is taxiing with a small turning radius.
If the profile grooves or the tread of new aircraft tires are worn, the tires can be repaired several times.
In some aircraft, there is a protection device to avoid the landing gear being inadvertently retracted on the ground. It consists of a latch located in the landing gear lever.
Tire creep may be described as the circumferential movement of the tire in relation to the wheel flange. The function of a scissor torsion link in a landing gear is to prevent any rotation of the oleo strut in the landing gear shock absorber.
A scissor link is a component found on landing gears. Its function is to prevent any rotation of the oleo strut in the undercarriage shock absorber. The auto brake system is disconnected during landing. By pilot action.
Nose wheel shimmy may be described as a possibly damaging vibration of the nose wheel when moving on the ground.
Thermal plugs are installed in wheel rims.
A red or an amber light on an undercarriage position indicator signifies at least one wheel is in the traveling or unlocked condition.
The reason for fitting thermal plugs to airplane wheels is that they prevent tire burst after excessive brake application. The reason for fitting thermal plugs to airplane wheels is that they prevent tire burst after excessive brake application.
The type of brake unit found on most transport acroplanes is a multiple disc brake.
Shimmy occurs on the nose wheel landing gear during taxiing when the wheels tend to describe a sinusoidal motion on the ground and the fork link. The damping element in a landing gear shock absorber used on large aircrafts is oil.
Generally, on modern jet transport aircraft, how can the landing gear be extended if there is a complete hydraulic system failure? By gravity extension.
In a commercial transport airplane, the landing gear normal operating system is usually hydraulically driven.
Which is other damping element in a landing gear shock absorber used on larger aircraft? Nitrogen and a viscous liquid. When a landing gear wheel is hydroplaning, its friction factor is equal to 0.1.
Landing gear torque links are used to prevent rotation of the landing gear piston in the oleo strut. A torsion link assembly is installed on the landing gear to avoid rotation of the piston rod relative to the gear oleo strut.
Generally, on modern jet transport aircraft, how can the landing gear be extended if there is a complete hydraulic system failure? Mechanically.
Over-center mechanisms in landing gear systems are used to lock the landing gear in the up and or down position.
The systems used for emergency extension of landing systems may comprise compressed nitrogen, compressed oxygen, and an auxiliary hydraulic system. Emergency extension of landing gear systems can be performed with compressed nitrogen by mechanical and manual means and by free fall.
The type of hydroplaning that is most likely to occur at the touchdown area located at both ends of the runway is called viscous. When there is a risk of hydroplaning, the pilot of an aeroplane should make a positive landing and apply maximum reverse thrust and brakes as quickly as possible.
For an aeroplane with a tire pressure of 14 bars, there is a risk of dynamic hydroplaning as soon as the speed is greater than 129 knots.
For an airplane with a tire pressure of 12 bars, there is a risk of dynamic hydroplaning as soon as the speed is greater than 119 knots. For an airplane with a tire pressure of 10 bars, there is a risk of dynamic hydroplaning as soon as the speed is greater than 108 knots.
For an aeroplane with a tire pressure of 8 bars, there is a risk of dynamic hydroplaning as soon as the speed is greater than 98 knots.
The modern anti-skid processes are based on the use of a computer whose input data is idle wheel speed measured, braked wheel speed measured, and desired idle wheel train slipping rate. The tire pressure of an aeroplane main landing gear is 10.8 bars. There is a risk of hydroplaning as soon as the speed reaches 113 knots.
One of the primary factors causing dynamic hydroplaning is the depth of the standing water on the runway.
Viscous hydroplaning occurs primarily if the runway is covered with a thin film of water and the runway is very smooth and dirty.
For an aeroplane with a tire pressure of 16 bars, there is a risk of dynamic hydroplaning as soon as speed is greater than 138 knots. Assuming contaminated runway conditions, if an aeroplane's main wheel tire pressure is 206 psi, the approximate speed above which dynamic hydroplaning may occur is 129 knots.
The tire pressure of an airplane main landing gear is 1566 p6 psi. There is a risk of hydroplaning as soon as the speed reaches 113 knots.
Planning for your flight, you are concerned about hydroplaning on takeoff. What formula do you use to calculate the speed for total hydroplaning? NBC explanation. V9 tire pressure in psi.